Have you ever been absolutely convinced you had this perfect idea for a system? Maybe an app, maybe some internal process.
Oh, yeah. Flawless in your head.
Exactly, flawless in your head. But then the moment you try explaining it to different people,
Mm-mm.
say engineers versus stakeholders,
It just falls apart. Lost in translation.
totally lost. That gap right there, that's what we're tackling today.
It really is. That translation issue is, well, it's a huge source of scope creep, project delays, all sorts of problems. It happens when you haven't clearly defined things up front.
And that's where the use case diagram comes in.
Precisely. That's why we're doing this deep dive. It's a key part of UML, the Unified Modeling Language.
Okay, so our mission today for you, the listener, is to get you that strategic insight.
Mm.
Not just, drawing circles and stick figures, but really using this as a blueprint.
A functional blueprint. Think of it like a contract. A use case diagram is basically a simple picture showing what the system has to do for the user. Its strength is its simplicity.
Right, cuts through the jargon, so non-technical people can actually get it.
Absolutely. It's classified as a dynamic or behavioral diagram in UML. Focused is purely on function.
And it's not exactly new tech, is it? I think I read somewhere it predates UML itself.
That's right. Ivar Jacobson introduced use case modeling way back in 1986. Shows how fundamental the concept really is.
Okay, let's get right to the value prop. If I'm managing a project, why draw this? Why not just, write a list of requirements? What does this diagram actually solve?
It solves the visualization problem, mainly. A list is just, well, a list. Hard to see the connections. A diagram shows relationships, boundaries, all at a glance.
So it helps visualize the functional requirements.
Critically so. It forces everyone, stakeholders, developers, to agree on the system scope really early. What's in the box, what's out.
Ah, the box. That must be the key thing defining what the system is and isn't responsible for.
Exactly. It draws that line in the sand. I remember one project, the devs assumed an external payment gateway was their problem to build reconciliation for. Big argument.
Out.
Yeah, but the use case diagram clearly showed that gateway as an external actor. Outside the box. Instantly clarified. Not our build, not our scope for that bit.
Saved a lot of time and grief, I bet.
Huge amounts. It prevents those massive misunderstandings about what you're actually delivering.
So communication is really its superpower then.
It really is. It's that translation layer. You use it to gather what users actually need, see how they expect to interact, and then you use it to communicate that functionality back to everyone involved.
Before you even write code.
Long before. It outlines those user interactions during design, making sure the CEO and the coder are basically on the same page about the mission.
All right, let's unpack the pieces. We've got the system, actors, use cases, and relationships. Maybe focus less on just the symbols and more on the rules.
Good idea. Let's start with the container, the system boundary, that big rectangle.
Okay.
Its job is just to define the scope. No negotiation. If something's inside the box, it's part of the system you're building or defining. Outside. External context. You might talk to it, but you don't own it.
And the system name goes at the top, like banking app.
Yep. Clear label. Now, outside that box, you have the actors. Stick figures.
Right, but the crucial point here isn't the drawing, it's the concept, right? It's a role, not a specific person.
You absolutely have to think of them as roles or categories. An actor is just something external person, another system, whatever, that interacts with your system to get something done.
So customer, administrator, credit bureau, not Bob or Alice the admin.
Exactly. Never specific people. If you use names, you're not modeling the general requirement. You're just describing one instance. It has to be the role, like customer.
And these roles, they have different types based on how they interact, who starts things off.
Correct. That gives us two main types. First, the primary actor. This is the one who kicks things off, initiates the use case to achieve their goal. By convention, you stick them on the left side of the diagram.
Okay, initiates. And the other type.
The secondary actor. They're reactive. They only do something after the primary actor, or maybe the system itself, does something first. They usually go on the right.
Can you give a quick example? Using that banking app idea.
Sure. A customer wanting to check balance, that's your primary actor. They start it.
Makes sense.
Now, maybe the bank's fraud detection system gets notified after the balance check completes, just to log the activity. That system is reacting. It didn't start the check, so it's a secondary actor.
Got it. Primary initiates, secondary reacts. Helps see the flow.
Definitely. Now, inside the boundary, inside the box, we have the use cases. Those are the ovals.
The functions the system performs. What are the key rules for these?
A couple of really important ones. First, the name inside the oval must start with an active verb. Log in, generate report, process payment. Always a verb.
Okay, verb first. What else?
Second, and this is subtle but vital, focus on the user's end goal, not just intermediate steps.
Ah, okay. Explain that distinction a bit more.
Well, submit order is a good use case. That's the user's goal achieved. But something like enter shipping address.
Yeah.
That's just a step within submitting the order. It's usually too granular for a top-level use case diagram.
I see. So login could be a use case itself because that might be a required goal before doing other things.
Yes, login often is shown as a top-level use case. But generally, you want the ovals to represent a valuable outcome for the actor. Oh, and just a practical tip. Try to arrange them somewhat logically inside the box if you can. Makes it easier to read. Okay, now for the connections. This is where the diagram gets, well, really powerful. The relationships define the system's actual behavior and dependencies. It's more than just lines on paper.
We start simple with association, right? Just a line.
Yep, the basic solid line connects an actor to a use case they interact with. It just means this actor uses this function. Simple communication link. An actor has to be associated with at least one use case.
All right. Now for the ones that always seem to trip people up, include and extend. Let's try and make this crystal clear for everyone listening.
We absolutely have to. These are critical. Let's start with include. This signifies mandatory required behavior.
Mandatory, meaning
Meaning the main use case, the base use case, cannot complete successfully without executing the included use case. It happens every single time. It's a dependency.
okay, so it's not optional. If I start use case A and it includes use case B, then B must run.
Exactly right. Think about our banking app again. Let's say you have withdraw cash as a base use case. It absolutely must include verify PIN. You can't withdraw cash without verifying the PIN, right? It's mandatory.
Makes sense. And the notation.
It's a dashed line with an open arrowhead, and here's the key. The arrow points from the base case, withdraw cash, towards the included mandatory case, verify PIN. And you label the line include.
Arrow points to the required piece.
Okay.
Got it. Include required.
Right. Like the old saying, if you sneeze, you will close your eyes as part of the sneeze process.
Huh. Okay, good analogy. Now, extend. This is the optional one.
Yes, precisely. Extend represents optional or conditional behavior, maybe error handling, maybe an extra feature. The base use case can run perfectly fine without the extending use case ever happening.
So the base case doesn't need the extended one to complete its main job.
Correct. The extended use case only runs if certain conditions are met. It's like an add-on, triggered sometimes.
Okay. And the notation, this is the confusing part, the arrow direction.
Right. This is the bit everyone mixes up. It's also a dashed line with an open arrowhead labeled extend, but counterintuitively maybe, the arrow points from the optional extending use case back towards the base use case.
Wait, why does the optional part point back to the main thing?
It's showing which use case offers the extension point. Think of it like the base use case has specific places, called extension points, where this optional behavior can hook in if triggered.
Ah, okay. So the base use case is running along, hits a certain point, checks a condition, and maybe calls out to this optional extending use case.
Exactly. Let's use login as the base use case again. Maybe it extends to show password reset option. You don't need the reset option every time you log in, right? Only if you fail multiple times.
Right. So login base can complete without the reset. But if I fail, the show password reset option, the extending case, gets triggered, and its arrow points back to login because login is the context where that extension might happen.
You nailed it. The base case provides the context or the hook for the optional behavior. If you sneeze, you might say, excuse me, optional politeness.
Okay, that clarifies it. Include arrow points to the required thing. Extend arrow points back to the base case from the optional thing. That direction rule is key.
It's absolutely key. And just a quick note, you can have multiple use cases include the same common function, like maybe transfer funds and pay bill. Both include check sufficient funds. Reuse is good.
Makes sense. You can also define specific extension points inside the use case oval itself for more detail, right?
Yes, you can list them explicitly if you need that level of detail, showing exactly where in the base use case's flow the extension can occur.
Okay, one more relationship type. Generalization? Sounds like inheritance?
It is. Basically, inheritance for use cases or actors. It shows and is a kind of relationship.
Yeah.
Parent-child.
So a child use case inherits from a parent.
Yeah, the child shares the common behavior of the parent, but adds its own specialization. For example, you could have a general parent use case, make payment,
Okay.
and then specialized child use cases like pay by credit card and pay by bank transfer. They both achieve make payment, but in specific ways.
And the arrow points?
From the specialized child up to the general parent. Solid line, closed arrowhead usually. Same logic applies to actors. You could have a general registered user actor.
With specialized children like standard user and premium user.
Exactly. They inherit the basic user stuff, but have different specific interactions.
Okay, we've got the parts and the glue. How do we actually build one effectively? If someone listening wants to start drawing, what's the best process?
Well, the sources generally suggest a pretty logical flow. 1. Identify your actors. Who interacts with the system? Think broadly users, other systems, even maintenance personnel.
Right. Anyone or anything outside the box that touches it.
2. Identify the use cases. What goals do those actors have? What does the system need to do for them? Does the system need to notify an actor about something?
Okay, actors then goals.
3. Draw the system boundary box and sketch the basic associations, who needs what function.
Get the basic map down?
4. Now add the logic. Define the in-charge. Include, extend, and generalization relationships. Where are the dependencies? What's optional?
Layer on the complexity.
And 5, critically, review and validate. Show it to everyone. Business folks, tech folks, users if possible. Does this capture what the system needs to do? Get that buy-in.
That validation step sounds crucial for avoiding those misunderstandings we talked about earlier.
It is. It forces the conversation and surfaces assumptions.
Now, these diagrams are great for the big picture, but what happens when a system gets really complex? Dozens, maybe hundreds of use cases. Doesn't it just become spaghetti?
It absolutely can. And that's where you need organization. For larger systems, the best practice is to group related use cases into packages.
Packages, like folders.
Pretty much, yeah. A package is just shown as a large rectangle with a tab, like a folder icon, inside your main system boundary. You might put all the use cases related to user authentication in one package and all the order processing ones in another.
So it helps manage complexity, keeps the diagram readable.
Exactly. It maintains clarity, which is the whole point of the diagram in the first place.
What are the common pitfalls? When people start using software for this, what mistakes do they typically make?
Oh, a few common ones. First, too much detail. Trying to show every single step inside a use case. Remember, it's what the system does, not how. Keep it high-level, goal-oriented.
Right, save the how for other diagrams, maybe.
Exactly. Second, inconsistent naming, calling it login here and sign in there. Use a standard glossary, be consistent, it avoids confusion.
Good point. Ambiguity kills projects.
Third, just sloppy visuals. Making ovals different sizes, lines crossing everywhere. Keep it neat, use alignment tools. Professionalism matters for clarity. And always make that system boundary crystal clear. Ambiguity there is fatal.
Okay, so be clear, be consistent, don't over-detail, and keep it tidy. Any specific tools recommended in the sources for drawing these, beyond a whiteboard, I mean?
Yeah, while sketching on a whiteboard is great initially, for sharing, editing, and maintaining, you'll want software. The usual suspects are mentioned. Lucidchart, Draw.io, which is free. Microsoft Visio is a classic.
SmartDraw, EdRaw Max.
Right. And for those who like text-based diagramming, PlantUML is really powerful. You write code like text, and it generates the diagram. Great for version control. #tagoutro.
All right, that brings us towards the end of our deep dive. So, to recap for everyone listening, you should now have a solid grasp of use case diagrams, what they are, the crucial role of actors as categories.
The vital difference between that mandatory include and the optional extend relationship, remembering those arrow directions.
And how generalization helps manage variations for both actors and use cases.
Fundamentally, this diagram captures the system's functional requirements. It defines the behavior the system must exhibit from the user's point of view.
It specifies what the system does. But as you said earlier, it doesn't really specify how.
Exactly. It deliberately abstracts away the implementation details.
So, connecting this to the bigger picture, that leaves us with a final thought, maybe a bit of cliffhanger for you to ponder. If the use case diagram nails down what the user needs the system to do, what's the next modeling tool you typically reach for to actually map out the sequence of interactions, the step-by-step flow inside one of those use case ovals to show how the system will achieve that goal?
Well, once you have what's defined here, to get into the how, the detailed sequence of messages between objects or components to fulfill that use case, you typically move on to creating a sequence diagram. That's where you map out the specific interaction flow.
Sequence diagrams. Got it. Something for our listeners to explore next, perhaps.
Definitely the logical next step for detailing the behavior.